Hello, let us introduce our tool STU to translate Stateflow into Uppaal. The source is the path of the MATLAB simulator file. The dest is the directory in which we put our generated Uppaal file. Let us show an example. If the dest is not set, it means the generated Uppaal file will be put into the directory which contains the source file. We translate this file, and the process ends successfully. We can see in the directory the Uppaal file is generated. We open the file with our Uppaal tool. This is the generated automation. We now use Stateflow to open the corresponding Stateflow model. The model has an implicit bug that is divided by 0. This action will be a divided by 0 bug. We run it step by step. After several steps, this action is executed, but the value of z is the maximum value of the integer. It is the divided by 0 bug. We find this bug by Uppaal. We verify whether when x equals to 3, y equals to 0. We write the property in the Uppaal verification tool, that is x equals to 3, y equals to 0. We check this property. Another property is satisfied, which proves the bug exists. Now we go to a more complex case, an industrial MVB case. In the MVB system, multiple MVBs connected through the central bus. Here we only model 2 MVBs. These states are the role of the MVB. There is a constraint. At one time, only one MVB can enter the regular master. The execution of these MVBs are controlled by the timers. Now use our tool to translate it into Uppaal. The process is successful. We open this model. We can see the logic is very complex. We have an overview about this. But luckily, we can just use the verification power of Uppaal. Now we will show how we ensure the correctness of our transformation. We will compare the simulation result with the verification result step by step carefully. And let it run randomly. We can see this is the timer. The time is increasing. We stop randomly at time 4. MVB1 becomes regular master. MVB1 enters regular master and MVB2 enters standby master. We will check this property. In Uppaal, we write the property at time 4. At time 4, MVB1 enters regular master and MVB2 enters standby master. We check this property. And the property is satisfied. Then we let the model run randomly and stop randomly. We stop randomly at time 15. The MVB1 enters state SR, MVB2 enters state standby master. We will check this property. In Uppaal, we check at time 15, MVB1 enters SR, and MVB2 enters standby master. We check this property. The property is satisfied. Keep doing this. We will ensure the correctness of our transformation. Now let us verify our final property. That is, whether 2 MVB can enter the regular master at the same time. We write this MVB1 becomes regular master, and the MVB2 becomes regular master. We check this property. And the property is satisfied. It means the brain split problem can happen. And now, this is the end of our video. Thanks for watching.